Hello, my name is Pratik Dey. So today we are doing a practical lab experiment, that is implementation and verification of truth table of 4:1 multiplexer and 1:4 demultiplexer. And this practical lab experiment is useful for digital electronics lab. Okay, so at first you need to be familiar about the terms multiplexer and demultiplexer. So this multiplexer and demultiplexer, these two are the digital circuit. Now multiplexer means what? Multiplexer means it is a digital circuit in which there are many input signal and one output signal. That means the main work of multiplexer is convert many input line into one output line, and demultiplexer just do the reverse operation. That means in demultiplexer there are only one input signal and many output signal, right? So as you see, that is the definition. Multiplexer generally means many into one. A multiplexer is a circuit with many input but only one output. Okay, and it has some selector, and there is a relation between the input line and selector, that is 2 to the power n is equal to m. That means here n is the number of selector and m is the input signal. So you see, so this is the truth table. Okay, so if we want to design a 4:1 multiplexer, we need two selector, right? Because 2 to the power 2 is equal to 4, right? So to design a 4:1 multiplexer, we require two selector line, right? So this is the circuit diagram. Now to perform this experiment of 4:1 multiplexer, we require a IC, that is 74153. Okay, so this is a IC in which there are two multiplexer. Okay, so just now we are doing this experiment by using Proteus. So you see, so just double click on Proteus. So when you double click, a screen will comes up. In that screen you need to click new project. So click on new project, and give any particular name. Okay, click on next, 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 and last finish. Okay, now you see, we need to collect this IC 74153. as you see here, this IC 74153. Now I just tell that in that IC there are two multiplexer. Okay, so this is the pin 1 2 3. This is the pin number 3 4 5 and 6. Okay, so just at first we pick up this IC 74153. So just type 74153. Okay, so just see this one 74153 multiplexer. Click on OK. Just click on here. Okay, now just little zoom it so that it is clearly visible to you. Okay, it is clearly visible to you. Now here there are two multiplexer. One is 3 4 5 6 pin number and another one is this 10 11 12 and 13. Now these A and B are the selector and this is the enable input. Okay, and this is the output of two multiplexer, right? So if we use this multiplexer, that means this 4:1 multiplexer, then we can use this output. Now if we use this multiplexer, then we can use this 2y as a output. Okay, so just we make this circuit. That means we have to make this circuit. You see, we have to make now this circuit. So just see this circuit. Here S1 and S0 are the selector, and here I0, I1, I2, I3 are the four inputs and Y is the output. So just now we are making this circuit. Okay, so just instead of I0, I1, I2, I3, okay, as you see, you make this circuit same like that. Okay, so just type the toggle switch. That means this toggle switch is the input, right? So just 4 toggle switch you require: 1 2 3 and 4. Okay, so these 4 are the inputs line. That means 4:1 multiplexer, right? So just click this 4 toggle switch as a input. Okay, do one thing. Just place this little above so that it looks fine, right? It looks fine. Okay, so these are the 4 input, right? Just rename it like that: I0, I1, I2, I3. Okay, so just click the text. This is I0, I0, right? So this is I0. Now this is I1. Okay, I1. Now this is I2. Okay, I2. I2 and this is I3. I3. Okay, so these four are the input, right? Okay, so this is the four input line. Now there are two selector also, so A and B are the selector, so just connect it. A and B are the selector, so connect it here and here. Okay, so this is the selector. You see the circuit diagram, this is the selector S0 and S1. Okay, so just rename it in this way. So A is S0 and B is S1. So this is S0 and this is S1, right? Okay, so you see the circuit is completing this circuit in this way. S0 and S1 are the selector, I0 to I3 are the input. Okay, so now we are use this 7 as a output, so we need to connect a LED, right? So just type on P LED, just type LED. Okay, now you choose your required. There are a number of list of LED. You choose the correct one. When a correct one means any one. You choose this one. Okay, now connect this LED. Okay, now you need a register also, so just click on register. So just click on register. So just click on register and you choose the generic register. Okay, so just click on generic register and change its value as 220 ohm, right? So change its value as 220. Click on OK. Okay, now its value is 220 ohm. So just click this output to the register and register to the LED. That means here the pin 7 is the output. We are able to see the output on this LED, right? So we need a ground. We need a ground connection. So click here a ground. Sorry. Just we need this ground. Okay, so click this ground here, and now I am telling you that these two are the enable input. Now this is active low, so we need this enable input into the ground, right? So click a ground connection and click this ground to this to LED. This to enable input to the ground. Okay, so the circuit is completed. Okay, so the circuit is completed. Now we have to simulate, we have to run this circuit. So we need to verify this truth table, right? You see, this truth table. Now if before showing the truth table, before verifying the truth table, I just want to clear you all that when the selector, this is the truth table, that means when the selectors are 0 0, at that time the input I0 is selected on the output line. That means what is the function of multiplexer? Multiplexer convert many input line into one output line. That means when the selector value, that means S0 S1 value is 0 0, at that time I0 input is selected on the output. Now when the selectors value are 0 and 1, that means A is 0 and B is 1, at that time you see the truth table that when this is 0 1, I1 is selected. Now when 1 0, I2 is selected. Now when 1 1, you see I3 is selected. So the same thing you are able to see. So now I run the simulation. Okay, so you see when this is 0 0, right? Now I0, you see I0 is selected. Look, I0. Now you see when you click on I1, there is no change. Okay, when you click on I2, there is no output. When you click on I3, there is also no change, right? But when you click on I0, only output is glowing. That means this I0 is selected on the output pin, right? This is for what? This is for 0 0. So you see here the first reading is successful. That means first verification is successful. For the selector value 0 0, the I0 input line is selected on the output, you see. So this is verified, right? Now we need to verify the second one, that means 0 1. So just we set it 0 and this S1 value is 1. Now you see which input is selected. Here you see I1. So just I do I0 1 not selected. Now I do this one, you see, not selected. Okay, you see one by one, you see one by one, right? That means for the case of 0 1, you see again for the case of 0 1, I1 is only selected. So just I on the I0, it is not selected. I just on the I2, it is selected. Yes, you see. So this is I2 is selected. Now you see for the case of 1 0, for the case of 1 0, I2 is selected, you see. For the case of 1 0, for the case of 1 0, you see I2 is selected, you see. So this is, you see, so the verification is successful. Okay, now for the case of 1 1, I3 will be selected. For the case of 1 1, I3 will be selected. For the case of 1 1, for the case of 1 1, you see only last one is selected, you see. I select the I0 but it is not selected. I on the I1, it is also not selected. I on the I2, it is also not selected, but I on the I3, it is selected, as you see. So the verification of this multiplexer is successful. Okay, so the verification of multiplexer is successful. Now we will do the demultiplexer. Now demultiplexer is just the reverse of multiplexer, you see. So in demultiplexer there are only one input line and many output line. That means for the case of 4:1 multiplexer, we need 4 input 1 output. Now for the case of 1:4 demultiplexer, we need 1 input and it will convert 4 output, right? So just to do this experiment, we required a IC, that is 74156. Okay, 74156. This is the demultiplexer IC. So just I stop this simulation, and we need a demultiplexer IC. So just clear the whole circuit, clear everything. Okay, so just clear all these things, clear all these things. Clear all these things and repeat the experiment again. So now we are doing demultiplexer. That means 1:4 demultiplexer. Okay. So delete all this. Just delete all this. So now we are doing demultiplexer experiment. That means 1:4 demultiplexer, right? So for this demultiplexer, we need a IC, that is 74156. Okay, so click on P button again and type 74156. So you see this is the demultiplexer IC. There is also one demultiplexer, that is 74155. It is also a demultiplexer IC. You choose any one, either 74155 or 74156, any one you choose. So I choose here. Okay, so now you see here in this demultiplexer IC, in this IC there are also two demultiplexer are there. That means numbered as 1 as 2, 1 and 2. So this 1C is the data input and 1E is the enable input. Similarly 2C is the data input of the second demultiplexer and 2E is the enable input of the second demultiplexer, right? And now this A and B are the selector, and there are also, as it has two demultiplexers, so it has 4 output of each demultiplexer. That means this 4 is for demultiplexer 1 and these 4 are for demultiplexer 2, right? So we are now making this circuit. So we need two toggle switch. So just little move it here. Okay. So we require two toggle switch. We require at first one toggle. Sorry, we require at first one toggle switch. logic toggle. So this is the toggle switch for data. Connect it to the data. And now as this enable input is active low, that means we require a ground connection. We require a ground connection. So click this ground here and connect it to the enable input. Okay, and now these A and B are the selector, right? So we require two toggle switch. So sorry, we require two toggle switch, logic toggle. So this is one toggle and this is another toggle. Okay, now connect this toggle into here A and connect this toggle into here B. That means here these two are the selector and this is the input and this is the enable input. And now there are four output. Now you see, as these four output are also active low, so we require four NOT gate. We require four NOT gate. So what is the IC number of NOT gate? 7408. So click on P button and type here 7404. This is the 7404 NOT gate. Okay, so click on it and just click on 4 NOT gate. This is 1, this is 2, this is 3 and this is 4. Okay, so for this 4 output, 4 NOT gate, we connect into 4 output line. So connect this here, connect this here, connect this here, and finally connect this here. Okay, so this 4 output is connected to the 4 NOT gate, and now we require similarly 4 LED. For LED also, so the space is very less, so I just little zoom out, you see. So this is for second LED, this is third LED, and this is fourth LED. And similarly we require 4 register also. So this is one register, this is another register, and this is another register. Okay, now we need to connect. So connect the first register, now connect the second register like that, and the output of this register to the LED. Similarly connect this one, this third output, here, Okay, the space is very low. So just little we need to redesign this one. Just move this LED to some another position. Okay, now it's fine. Okay, now click on it. Okay, so again click this LED little here. Now we require also for ground connection also, so click on ground and connect this ground here. One ground here, another ground is here, and another ground is here. Okay, so connect this to this register and connect this register to here. So our 4 output line is completed, right? So this is the data output. 4 data output are there. This is one input, so just name it. You see the circuit. The circuit is very easy, you see here. Okay, so the selector is AB and this is the input data and this is the output. 4 output, Y0, Y1, Y2 and Y3, right? So just name it in this way. So this is the input data, you see here, data I. So just type it here, text, type a text, type a text, type a text, data I. Just type data I. Okay, click on OK. So this is data I, and now this AB is what you see. This AB are the selector. Okay, this AB are the selector, so you need not do anything. This AB are the selector. Okay, and now these 4 are the output. Y0, Y, you see here in the circuit diagram, Y0, Y1, Y2 and Y3. So just name it like that. So this is Y0, Y0, and this is Y1, Y1. Now this is Y2, Y2, and finally this is Y3, Y3. Okay, so the circuit is completed. Now the demultiplexer circuit is completed. This is 1:4 demultiplexer. Now we need to verify it, right? So just see the truth table. We need to verify this truth table. You see the truth table here. Okay, we need to verify this truth table. You see, now you see we need to on the input line. That means here we run the simulation and we just make the input line into 1. Now you see the truth table here. You see, for the case of 0 0, that means this 2 selector is 0 and 0. You see, the 2 selector is 0 and 0, right? So you see the truth table. At that time only y0, that means first in output is selected, right? So you see the first output y0 is glowing, right? First output is glowing. Now you see, for the case of 0 1, you see, now I am doing 0 and this one into 1. Now for the case of 0 1, you see here, for the case of 0 1, the y1 is selected, you see. So just do it 0 1. Oh, little problem. So stop simulation again. We need to change this register value, right? We need to change this register value to 220 ohm. So 220 ohm, click on OK. We need to change this 3 register value, 220 ohm, we need to change the resistance value to 220 ohm. Click on OK, and then again this one, two to 0. Click on OK. Okay, so now run the simulation again. Okay, now you see the truth table. For the case of 0 and 1, y1 is selected. You see here, you see this one is selected for the case of 0 1, right? Now you see for the case of 1 0, you see, so this is we are doing 1 and 0. You see this one, for the case of 1 0, y2 is selected, you see, right? This is selected. Now for the case of 1 1, for the case of 1 1, y3 is selected, you see. For the case of 1 1, you see, y3 is selected, right? So in this way you are able to perform this demultiplexer experiment. So by this experiment you are able to perform 4:1 multiplexer and 1:4 demultiplexer. So thank you very much.